Hello students. Now we will go towards this economic order quantity examples. Previous lectures we discussed about how we are finding out the optimal quantity QO, and then we are discussed the other things also, and near the orders we are also discussed. So we will discuss now the first problem. Problem statement is like this. An oil engine's manufacturer purchases lubricant at a rate of Rs rupees 42 per piece from a vendor. The requirement of these lubricants are 1800 per year. What should be the order quantity per order if the cost per placement of an order is Rs rupees 16 and inventory carrying charges per rupee per year is 20 paise. Okay, this is the input data they are giving. Rate of lubricant is 42 rupees, and then quantity is 1800 per year. Then what we have to find out? We have to find out ordering quantity per order, and this cost per placement of order is 16 rupees, and inventory carrying charges are per rupee per year 20 paise. Okay, so we have to find out this ordering quantity per order. So we will start with the capital D, which is the number of lubricant to be purchased, 1800 per year. Procurement cost, that is cost per placement is C3 is 16 per order. Inventory carrying, that is C into I, that is the C1 is equal to the C value is 42 rupees, and I value is inventory carrying cost is per year is 0.20, so it is equal to the 8.4 per years. So then optimal quantity EOQ, Q0 is equal to the square root of 2C3 capital D divided by C1. So our ordering quantity per order QO is equal to the 82.8 or 82.8 or 33 lubricants per uh, per order we have to order. This is the answer for the this particular example. Now move towards the second example. Statement of the problem is like this. Manufacturing company purchases 9,000 parts of machines for its annual requirements, ordering for month usage at a time. Each part costs the 20 rupees. The ordering cost per order is 15 rupees, and carrying charges are 15% of the average inventory per year. You have been assigned to suggest a more economical purchase policy for the company. What advice you offer, and how much would it save the company per year? Number of lubricants to be purchased is 9,000 parts per year. Cost of per part is that we are having cost per part is we are having 20 rupees. Then procurement cost is C3, this per order is 15 per order. Inventory carrying cost is C into I, so it is C1 is equal to the 15% of the average inventory per year. Cost per part cost is 20 rupee into the 15%, that is 3 rupees per each part per year. 3 rupees for each part per year. So optimum quantity EOQ is equal to the square root of 2 into C3 into capital D divided by C1. So C3 value is given as 15, D is quantity is 9,000, and C1, that is inventory carrying cost, C1 is equal to the 3. So QO0 is equal to the 300 units per year. That is optimal economic order quantity for this, or the optimal quantity EOQ for this given problem. So this is the solutions for the this particular problem. Now we will move towards the next part, that is the optimal order interval. What should be the optimal order interval? So that TO is equal to the Q0 divided by D in year. Q0 is optimal order quantity divided by total quantity. So in year we are having 1 upon 30 year. So what we have to do? We have to order after 122 days. Minimum average cost, we are having the formula like this. Minimum average cost is equal to the square root of 2 into C3 into capital D into 1. So it is C3 is the inventory cost which we are having, D is the total cost, and C1 sorry, inventory cost is a C1, C3 is a cost per order which we are having. So which we are having 2 into 3 into 15 into 9,000 is equal to the, so overall this result is equal to the minimum average cost is 900. If the company follows the policy of ordering every month, then annual ordering cost is uh, RS 12 into 15, it is equal to the 180. Lot size of inventory of the each month is 9,000 divided by 12. So it is equal to the 750. So average inventory at any time is Q2 divided by 2. So it is equal to the 375. Therefore, storage cost at any time is 375 into C1. It is equal to the 1125. Total annual cost is 1125 plus 180, that is equal to the 1305. Okay, so if I consider the monthly, we have to going for this. Uh, so hence the company should purchase the 30 parts at a time interval of the 30 parts at a time interval of the uh, 1 upon 30 year, instead of the ordering the 175 parts each month. The net saving of this company will be, the uh, 1305 minus 900. So it is equals to the it is equals to the 405 per year will be the total saving of this particular. So like this we can solve this particular problems by using this EOQ formula. Okay, this is about the problems which is asked on the this EOQ or the economic order quantity techniques. So I hope that it is clear to you. This is the last part of this our third unit. So we have to, in this particular units we are having the problems like we have to go with this material management. What is the material management, functions of the material management, all these things which we have to go through this particular, and whatever this points which we are discussed previously also, that we can also have to go through this all these things, and we have to have these things. We have maybe asked the questions on the purchasing. What is the importance of purchasing steps in the purchasing? Then what is the inventory control? What is the importance of inventory controls? What are the techniques of the inventory control? That is also the things which we have to go through that. This in on the purchasing also, the these parameters of the purchasing may be asked 5 hours. What are the 5 hours? This will maybe also be asked. All these things, the theoretical questions. Along with that, some problems may be asked. So two types of problem we are discussed here. They may be asked also in these things. Okay, so this is about the things. I hope that everything is will be clear through this video. If you have any doubt or anything, you can contact to me. Thank you very much.